Hello, friends. In the previous session, we have explored various techniques involved in designing a scalable distributed system. We started our journey by creating a simple client server setup over the internet. In this session, we will expand our existing system with horizontal scaling approach using a load balancer. So, this is the design which we were discussing in our previous session. We started our design with a very simple client and server setup. Now, in this case, when network traffic at our client increased, we have we added one more server on the farm, and we are using a load balancer to coordinate the communication between these servers on the farm. So load balancer is a central component which distribute the network traffic among various server on the farm using various techniques to accomplish that horizontal scaling. So this client, similar to our previous workflow, will request a connection to myserver.com. DNS will resolve the IP address. DNS will contain the public IP address of the load balancer. And load balancer will coordinate with web server using their private IP address. So this kind of design prevents an external access of these web servers by clients directly using their private IP addresses. Now the focus of this session is more on the system design. Therefore, we will not go into too much detail on these load balancers. But there are certain things which we are supposed to know. In this case, the load balancers can be of two types: hardware based load balancers and software based load balancers. So, as the name specifies, a software based load balancer, in this case, load balancer as a service, is some kind of a software application which diversify or distribute the traffic on this various servers on the server farm. Similarly, a hardware based load balancer is a hardware device with a specialized operating system which distribute the traffic on the server based on the logic available on this hardware based load balancer. Now, the question of choosing which one is better, it actually depends upon various factors which is out of scope for this discussion. But you can you can assume that software based load balancers will be like more elastic, and hardware based load balancers are basically more secure. Now the load balancers can provide several benefits. For example, when in this case when one of the web server goes down, then load balancers will automatically shift the traffic to another web server, and when that web server comes back, uh, it will redistribute the traffic on these servers. So this way it can deal with various failover issues. Similarly, it also provides a flexibility to add or remove server from the farm if required. Now, now, load balancer can choose various technique to choose a server from a farm. These techniques are generally categorized into two types. They are called static methods and dynamic methods. We will see all these methods one by one. Now, round robin is one of the most simplest static load balancer algorithm. So in this method, load balancer will distribute this request in a circular order or in a sequential order. As soon as it receives a request from the first user, it will assign that request to the first server available on the form. When it gets the next one, it will assign it to the next server. After that, when it receives a request from the another user, the third request, it will assign it to the third. server. When it receives a fourth request from this particular user, it will go back to the first server and it will assign it. Now, the benefit of this approach or is algorithm is it is very simple to implement. But the drawback is it is not that efficient because load balancer is not aware of the server load. For example, if server 2 is already overloaded due to the type of request which this particular user uh, has sent, irrespective of that, when load balancer receives a request, it automatically assigns a request to that particular web server irrespective of how busy that server is. The second drawback of this kind of approach is load balancer is not aware of the sessions. For example, in this case, if a user is sending its first request, its request gets assigned to the first server. When the user sends a second request, the request gets assigned to second server. But if there is a dependency of that second request on the first request, load balancer won't know. Now let's see a small animation to better understand this workflow. Now let's see another algorithm, sticky round robin, which is a variation of the previous round robin algorithm. Now the advantage of this algorithm is if this user's previous request or the initial request went to web server 1, all its following requests will also go to web server 1. So this way, this sticky round robin resolves the issue where if there is a dependency between the request, it will be always processed on the same web server. Now let's see a small animation to understand sticky round robin. Weighted round robin is another variation of round robin. In this case, admin can specify weight for each server. This weight can be determined based on various factors like a processing power of the server. In this particular example, web server 1 has the highest weightage and web server 2 has the lowest. So in this case, we are assuming that web server 1 has more processing power compared to web server 2 and web server 3. So when load balancer gets a request, it will make sure that most of these requests are assigned to web server 1. So in this case, the server with a higher weight handles more requests than others. Now let's see an animation to better understand weighted round robin. Hash-based static load balancing algorithm is also very popular and very convenient to use. This algorithm applies a hash function on the incoming request. So this incoming request will contain IP address or a URL, and some kind of hash algorithm is used to generate a hash key. Admin will configure web server 1, 2, 3 in this case to process hash key 0, web server 2 to process hash key 1, and web server 3 to process hash key 2. Assume that when a load balancer is getting a request from user A and it is transforming it into hash key 2. So automatically load balancer will forward this request to a processor which is configured to process requests from hash key 2. And when it receives a request from this particular user and its IP address is getting resolved to hash key 0, load balancer will automatically forward all these requests from this user to this server which is configured to process hash key 0. Now let's see an animation to understand hash based algorithm. Static load balancing algorithms are easy to implement, but they are not efficient. We can resolve these issues by using dynamic load balancing algorithms. Dynamic load balancing algorithms take into consideration the latest status of these web servers, which keeps changing all the time. And based on their availability and based on their various situations, load balancer will pick up the best possible web server available on the farm. So in this series, the first algorithm which we will see here is the least connection based. For example, in this particular situation, web server 1 has 1000 current active user connected to it, and web server 2 has 500 current active connections associated with it, and web server 3 has only 100 connections associated with it. Now when a request will arrive at load balancer from various users, it will always check which one is the best possible web server at this point of time. In this case, obviously web server 3, because web server 3 has lowest active connections. So in this case, a new request, whenever it arrives on the load balancer, is sent to a server instance with the least concurrent connections. Now let's see a small animation to understand least connection based dynamic load balancing algorithm. There is another algorithm which load balancer can apply to pick the best possible server from the server farm. It can determine the server based on their response time. For example, in this particular case, at a particular moment, web server 1 is returning responses in 10 milliseconds, web server 2 is responding in 100 milliseconds, and web server 3 is responding back in 1000 milliseconds. So load balancer will always keep track of the current status of these response time. And every time a request comes, it will always redirect the request to the best possible server which is responding in the least response time. Now let's see a small animation to understand how a load balancer is picking up server based on the least response time. So in this session, we have seen how we can apply a load balancer to achieve horizontal scaling and coordinate between multiple web servers. In the next session, we are going to see how can we use or how can we improve our design by introducing a database into our systems. Thanks for watching.